Hello, it is time to start Chapter 4. Chapter 4 is all about quadratic functions, so parabolas, how to graph them, how to factor, how to solve them in a bunch of different ways. We're starting out today with Section 1, which is about graphing quadratic functions. Most of this is review from Algebra 1, but we might need refreshing on some of the different parts. So our goals today are to be able to graph quadratic functions, and we're talking not just about sketching them, but about graphing them precisely, and then to be able to find and interpret what the maximum and minimum values of a quadratic function are and what they mean. So there's a bunch of vocabulary you should be looking for in today's lesson. I'm not going to write out all of the definitions right here, but these are the different words that you should be able to define or be able to talk about and recognize at the end of this section. All right, so when I'm graphing a quadratic function, first of all, a quadratic function has a degree of 2. A degree of 2, meaning its greatest exponent is 2. These functions normally can have 3 terms. The quadratic term, so the term with the x squared, the term with the x is called the linear term, and the c, or the plane number by itself, is called the constant term. Of course, a cannot be equal to 0, because if a were 0 here, then this would just look like bx plus c, which would be a linear function instead of a quadratic one. But b and c can both be 0. So sometimes you'll have a quadratic function that just looks like y equals 3x squared, or something like that. In that case, a would be 3, but b would be 0, and c would be 0. All right, the graph, as we already talked about, is called a parabola. And to graph the quadratic function, we graph ordered pairs and we make a table of values. So we're going to start out just looking at making a table of values kind of just at random. And then we're going to talk about some different ways to figure out exactly where to start your table of values so that you can always make sure to have the right points to graph your parabola. So we're going to start out with this parabola. F of x, or y, equals x squared plus 3x minus 1. So in this case, a, which is the number in front of x squared, would be 1. B is 3, and C is my constant, -1. All right, so we're going to just plug in some values to make a graph. Remember, anytime you're not sure how to graph, you can always plug in some x's and get some y's, and you get a bunch of coordinate pairs or ordered pairs that you can connect with a smooth curve to make the graph. So here we have a table. Notice they plugged in -3. So I have -3 squared. Notice the parentheses around the -3 so that we get +9. Then I have 3 times -3, which is -9. So I have 9 plus -9, which is 0, minus 1, which is -1. So when I plug in -3, I get -1. And here is that point graphed on this graph. When I plug in -2, I get -3. So that's this point. When I plug in -1, I get -3. When I plug in 0, I get -1. And when I plug in 1, I get 3. So notice they connected these with a smooth curve. Notice that between these 2 points that both have a y value of -3, they didn't just connect them straight across, because parabolas are smooth curves. They're not going to have like just a straight part like that. So they dipped down between them. They knew it had to turn back around and come up. But this part right here would be the vertex, and in a few slides we're going to learn exactly how to find that. So this would be the graph of my parabola. Okay? So you guys try this one. Make the table of values and graph it. Okay, you should have ended up with C, so the values that they're showing you here are -2, 4, -1, 1, 0, 2, and 1, 7. Okay, you might have gotten a few different values, but hopefully you chose enough points so that you saw where the parabola turns around. Remember, parabolas always graph as a U shape. It can be skinnier, wider, upside down, but it always looks like a U. Okay, so in that first example, if we go back to the table that we made, notice that there's kind of a pattern that you might see in the y values. Both of these y values are the same. Both of these y values are the same. And if you'll notice, this point, that's the point 1, 3, over here is the point -4, 3. So they have the same y value. So I have a whole bunch of points that are symmetrical around the middle of my parabola. That is always going to be the case. Parabolas are always symmetrical. And they're symmetrical around a line that we call the axis of symmetry. The axis of symmetry is this line that goes right down the middle of the parabola. We usually put it in as a dotted line because it's not actually part of our graph, but it helps us to make our graph more precise. So the axis of symmetry divides my parabola into two exactly congruent reflections of each other. So for example, if we look here at point B and point C, point B is at -1, 1, and point C is at 7, 1, and they are equally spaced on either side of the axis of symmetry. So this axis of symmetry goes through the vertex. The axis of symmetry will always go through the vertex. In this parabola, my vertex is 3, -3. So notice that point C, which is set at 7 on the x, is 4 units away from the axis of symmetry. And point B, which is at -1 on the x, is also 4 units away on the other side from the axis of symmetry. That's going to be true for all of the points on my parabola. And again, my axis of symmetry always passes through the vertex. The vertex is the middle point of my parabola where my parabola turns around. Okay, so let's look here at this table. This gives me a lot of information that's going to help me graph my parabolas more precisely. So here we have the general form of a parabola. Y equals ax squared plus bx plus c. Of course, a cannot be 0. My y-intercept, which happens when x equals 0, if I plug in 0 to this equation, I get 0 plus 0 plus c. So c is my y-intercept, or the ordered pair 0, c. Here is an important part that's going to help us graph much more precisely. The equation of the axis of symmetry is x equals -b over 2a, or the opposite of b over 2a. That might ring a bell and should ring a bell from Algebra 1. We are always going to use that when we start graphing a parabola from scratch by hand. And because that's the equation of my axis of symmetry, notice it's x equals a number. This is just going to be a number. It's a vertical line. Because my axis of symmetry always goes through the vertex, my vertex is always going to have the x-coordinate of -b over 2a, and then I would plug that into my equation to figure out what the y value is at that specific point. So this formula serves two purposes. One, it gives me the vertical line that's the axis of symmetry, and two, it gives me the x-coordinate of my vertex, and that tells me exactly how to set up my table of values, which I'll show you in a second. So let's look at this example. I have this function, 2 minus 4x plus x squared. Notice my biggest exponent is a 2, so I expect a parabola, expect my U shape. We're going to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. First of all, we're going to arrange this so that they are in the right order so that we can identify a, b, and c. So we're just going to rewrite x squared as my first term, -4x is my second term, and +2 is my third term. So that means that my a is 1, b is -4, and c is 2. A is always the coefficient of x squared, b is the coefficient of x, and c is my constant. So we're going to use those numbers to find our axis of symmetry and our y-intercept. Our y-intercept, remember, is always c. So my y-intercept is 2, or as an ordered pair, it's 0, 2. So now I already have 1 point on my parabola. To find the axis of symmetry, we're going to need to use a and b. So we're going to use this formula. This is the equation of the axis of symmetry. Since b was -4, I plug that in. A is 1, so 2 times 1. And when I simplify, I get basically +4 over 2, which is 2. So x equals 2 is the equation of the axis of symmetry. Remember, the equation of the axis of symmetry is the same as the x-coordinate of the vertex. So that means that my vertex is going to have an x-coordinate of 2, and in a second we're just going to have to figure out what the y-coordinate is by plugging it in. Alright, so we're going to make a table of values here. Because we know that my vertex has x value of 2, we are going to make sure that we pick some x values less than 2 and greater than 2. So basically what you want to do is anytime that you make a table of values, you want to start with the vertex, you put that x value in the middle, and then you pick at least 2 values less than that and at least 2 values greater than that. So when we plug in 2 to our equation, to our function, we get -2, so that's my vertex. When I plug in 1, I get -1. And notice when I plug in 3, I also get -1. That's because of that symmetric behavior of parabolas. As long as my x values are equally spaced from the vertex, so both 3 and 1 are 1 unit away from 2, I will have the same y value come out because parabolas are symmetric. When I plug in 0, I get 2, which we already knew, that's our y-intercept. And when I plug in 4, I also get 2. So now we're going to graph that. We're going to graph our vertex, we're going to graph our y-intercept, and we're going to graph all of the other points from the table, and we're going to draw our parabola, and then we're going to draw in our axis of symmetry as a dotted line to make sure that our parabola is symmetrical. So your graph should look like this. Here are my points: 0, 2, 1, negative 1, 2, negative 2, 3, negative 1, and 4, 2. Notice they drew in the axis of symmetry as a dotted line, and they connected them with a smooth curve. This is not a V like absolute value. The parabolas are more U-shaped, and that would be my final graph. So now I want you guys to try that on these next 3. Here's the first one. All right, your answer should have been C. You should have gotten a y-intercept of 3 because that's your C value. Your axis of symmetry is x equals 3, which is also the x-coordinate of your vertex. And there's the work for the axis of symmetry if you need that. Okay, try this one, table of values. Okay, the proper table of values is D, the one that matches this parabola. In this case, notice that they put their vertex here, and they did 3 points on one side and only 2 on the other, but you can still see the symmetry, right? Your vertex should always be somewhere in the middle so that you get points on both sides. And try C, which one of these graphs is correct? All right, it should be A. There's your axis of symmetry of x equals 3. And then those points should match the points on the table of values. Okay, maximum and minimum value. This is kind of the last big thing from this section. Because parabolas are U-shaped, they can open up or down, depending on what your A value is, and they're always going to have either a minimum or a maximum point because of that U-shape. So if my parabola opens up, which happens when A is positive, remember A is the coefficient of x squared, then that vertex is going to be my minimum. And the y-coordinate of the vertex is called the minimum value. Okay, so the x-coordinate is not the minimum value. The y-coordinate we call the value of the function. If my parabola opens down, which happens when A is negative, so like negative 2x squared, then that vertex point is the maximum of my function because my function goes forever down on both sides. This is the highest it could ever get. And again, the y-coordinate is called the maximum value in that case. So let's look at an example here. We want to look at this function and we want to figure out if it has a maximum or a minimum value. To do that, we look at the A value. In this case, A is negative 1. Since A is less than 0, since A is negative, my graph opens down. And if my parabola opens down, then my vertex is the highest point, meaning that it has a maximum. It has a maximum value. Now what they want us to do in this next part is to figure out what the maximum value is. To do that, we need to find the vertex. Okay? We need to find the vertex to find the maximum value. So here's the work that we would need to do. Step 1, I need to find the x value of the vertex by using my formula, negative b over 2a. And when I do that, because my a value is negative 1 and my b value is 2, I get positive 1 for the x-coordinate of my vertex. But they want the minimum or maximum value, which means I need the y-coordinate. To get that, I take my x value of 1, I plug it into my function, and I get 4. So my vertex is 1, 4, but my maximum value is 4. Remember back here we saw that it has a maximum because it opens down. That maximum value is the y value of the vertex. So using that information, we're going to talk about the domain and range. We know that the domain is all real numbers because this is a parabola. I'm allowed to plug in as many x's as I want, all kinds of x's. So the domain is going to be all real numbers. The range is going to be all numbers less than or equal to the maximum value. So if you think about what the graph looks like, that makes sense. The range is going to only be able to go up to 4, and it's going to be all the numbers below 4. So the range is going to be the set of y, or the set of f of x, such that f of x is less than or equal to 4. All right, I want you guys to try these next 3. Try this one. You should have gotten that it has a minimum value. And this one. When you plug that x value in, you should get -5 as the minimum value. And here's our last one. The answer is